welcome everyone, and thank you for joining us this morning on a session on spectrum for 6G. I know that my name is Joanne Lemay. I'm co-president of LY International. We're a consultancy based in Montreal, very active in spectrum. And I know that 5G networks are getting deployed, but it's probably not too early to start talking about 6G. And we have a fantastic panel today to talk about spectrum for 6G. So without further ado, since I know we only have 30 minutes, so I have Christina Data from Ofcom to my left, and Doug Kirkpatrick from Eridan, Marie Hogan from Ericsson, and Ayman Mohedin, which I'm sure I haven't said right, from Nokia. So everybody will have a brief little introduction, 2 minutes, and then we'll get started on a discussion. Unfortunately, because we only have 30 minutes, if you have questions, then maybe you can wait till the end and come and see everyone individually. So Christina, why don't you tell us what your first view is, spectrum for 6G?
Thank you very much, Joanna, and good morning, everyone. Clearly, I'm going to be a bit controversial and actually start, before tackling the spectrum, what is 6G? What is the new 6G technology? Is it just another G? Is it just another mobile G? Or actually, are we talking about converging technologies providing different solutions, different technological solution, network deployment solution to different problems? We have been talking about next generation wireless broadband as our view of 6G in the UK, because you've got all of a sudden technology like satellite, direct to device, that is becoming more, is having more of a role actually in offering solution where there isn't the terrestrial coverage that is needed. So we prefer to look at it in the round. Clearly, the spectrum is important, and we've just finished a WRC round, and we're starting a new WRC round for 2027. Some spectrum has been identified. It all comes with challenges, and some spectrum has been identified in slightly different way in different regions. We have made a lot of spectrum available up until now for wide area mobile, yes. We've also made spectrum obviously available for other technologies, but I think we're now at a moment in which the paradigm needs to change. We need to make sure that we consider incumbents, particularly in the 6G IMT identified spectrum, and therefore we're looking at a sharing coexistence by design, new protocol in the future of spectrum management.
Thank you. And Doug, why don't you carry on the, we don't need any more spectrum.
So, from a technology perspective, we don't need any more spectrum. The challenge is not spectrum. The challenge is pushing the technologists to give the pieces that you need. We have probably spectrum in the wrong places. We probably need to think about what spectrum we want to use for what kinds of applications. And that probably means that we'll need an intermediate, because moving applications from one spectrum to another is not a zero-sum game. You're going to have a transit time period in between there. So we probably will need some intermediate amount of spectrum in order to be able to make those movements happen. But when we're done, the answer should be zero.
Okay, that's interesting. Like I said, we don't have representatives from a carrier on the panel, so I will do that to a certain extent. So I'll probably push back on this a little bit, but we'll see about that. Marie, please go ahead and, for Ericsson, please explain to us how you see this.
Yes, so I absolutely agree with Doug on the points that we can do a lot more on the technology side of things. We can do a lot more on spectral efficiency. We can clearly utilize the spectrum we have today in a more optimal way. We can use traffic steering. It's about building radios that can have more reach, getting the most out of the existing grid. But then I don't agree, I think, on the point that we need no more spectrum. I think when we're starting to look at what we would expect a network to be able to do 8, 9, 10 years from now, we see it being able to do a lot more than the type of mobile broadband that we have today. So if you take things like bringing immersive communication outdoors into a mass market, using it for maybe societal good, addressing more immersive ways of traveling or educating or training, and thus cutting down maybe environmental impacts. If you think about having a global broadband affordability for all, you can think about use cases like digital twinning, which we have started in 5G, but are very localized. If you talk about taking those out to maybe a more wide area, mass market, more data, I think we clearly see a need for more spectrum, but I would fully acknowledge, of course, there is no free spectrum. So I think as an industry, we need to do a lot of work in the next few years about how we can share or coexist in this space.
Okay. So shared spectrum is really top of mind.
Yes.
In your case. So if I'm an operator, I really want exclusive high power spectrum. That's really what I'm looking for. But maybe, and I know I'm being pushed to share. So, Eamon, from the Nokia perspective, and your work on standardization.
I would see it a little bit different. Repurposing some bands to carry on the new network, because if you know that in 4G, there was the revolution of the information technology and social network. We come to the 5G, we had sort of massive machine-to-machine communication, and we know how to do it. But when we come to the 6G, we are going to have a different use cases, as been said by Ericsson, that they have said that there will be the digital twin. Repurposing some bands for that when you have a legacy system is not an easy topic, and it's a little bit challenging. So if you wanted to have and flourish the 6G use cases, you definitely need an additional spectrum to the existing spectrum. And we have studied that, and we have found out you need, beside the existing spectrum which they have, you need to have between 500 to 700 megahertz per network to complement that one, at least to reach that vision of 6G.
So, okay, so that's good. You answered the question. How much spectrum? 500 to 700 megahertz per company, right?
Yes.
Per network.
Yeah.
So in a country with 3 or 4, we're talking up to like 2.8 gigahertz of new spectrum that could be or repurposed or new or repurposed. That's a lot of spectrum.
That's a lot of spectrum.
I mean, if I want to start talking about bands, I mean, I know at WRC 27 there's 4.4 to 4.8. There's a 7 to 8 gigahertz, 14 to 15 that are going to be studied. That doesn't add up to 3 gigahertz, right? Anybody want to take that on,
Well,
Christina?
I would say yes, there are some challenges already in having identified that spectrum, let's be honest, because it doesn't come free, as you were saying, Marie. So this is why this new paradigm of sharing is necessary. There is also millimeter wave. We have discussed before. It has potentially not delivered as much, but where there are specific use cases, we have looked at in the UK in making it available really targeted in high-density areas, because we think that's where that particular spectrum, we also discussed not every bit of spectrum is born equal. Well, clearly millimeter wave spectrum is very different from anything down the bottom, and potentially in the top 14 gigahertz of the 3 bands chosen at WRC also falls into that category of a little bit more difficult than definitely what is in the centimeter wave sort of environment. In the UK, I know this is a region 1, upper 6 gigahertz has also been identified for IMT, and the UK is very, very keen and has pushed for an hybrid solution, because the US has been deploying Wi-Fi in that spectrum. So how can we make sure the two technologies actually can share, can coexist? Because we were discussing on the panel, the type of demand that we're seeing is different, is geographically different, is indoor versus outdoor, is rural versus urban or suburban, etc. So again, how can we optimize the spectrum that we're making available for the applications that are needed by consumer? And I just wanted to rectify, I'm not saying we don't need more spectrum, I'm just saying we need to make available as regulators spectrum in a slightly different way from the past. The idea of spectrum everywhere, wide area, nationwide is different. And they've already started with 38242 for private networks and with the approach that we're proposing on upper 6.
There's two pieces And I think we had an earlier discussion. We need the right spectrum for the right application. So if we're talking doing IoT farms, you're out in the middle of nowheres. You need really long reach. You want to do that as low as you can go. If you're in a highly densified environment, you want to get as much spectrum reuse, spot to spot to spot as you can. Moving higher in bands in frequency spectrum means that it hits a piece of drywall and immediately dissipates. It doesn't go as far, so you can reuse that spectrum over and over and over again. Doing higher frequencies out in the middle of nowheres makes no sense. Doing lower frequencies that are going to propagate and create interference in an interference-dominated environment makes no sense. I think we as a team here can all look at that and say, there's a right way to do this. The other layer that's underneath that is we as a community need to push us as technologists to be able to say, these are the kinds of things that will be very high value add. So if I'm looking at low frequencies and I can figure out how to do 1024, 4096, 16384, 64K QAM, I'll be ridiculous, 17 megaQAM, and I can push 32 bits per hertz, and I can reuse that spectrum 32 times in a phased array laydown. That's incredibly valuable. We had this little joke on the side, chuckle, going to terahertz, not helping.
Yeah.
So
but there's a lot of talk of terahertz for 6G.
There's a lot of talk, and those of us who are in the real world need to go, guys, time out. Time out. This makes no sense. Okay. So we need to take the scarce R&D dollars that we as a humanity have and say, focus it here, guys. This is what's going to matter. And that's what we as a community have to be doing, because that is what's going to raise the opportunities for somebody in the regulated environment to come around and say, this makes sense, that makes sense, that makes sense. That's why I turn around and say 0, but it's not an easy journey.
Yeah, well, you mentioned temporary spectrum. I'm not sure that anything would be temporary, but Marie, would you want to chime in on the same issue?
So I think as as an industry and an ecosystem, there are a few aspects. There's for sure, the lower the spectrum, the better for coverage. Then somewhere there's a sweet spot around the what we call mid-band. Maybe that's 2 to 6 megahertz, where you have quite a lot of data, but you also have a good coverage. And then the further up you go, as Doug mentioned, the coverage gets more challenging. So there are a lot of things we can do from all sides, from the device ecosystem to the infrastructure to the regulators. We have countries where spectrum can't be used because in 3GPP we have defined carrier bandwidths, and then maybe it's 5 megahertz, but the allocated spectrum is 7. So what do you do with this little bit on the side? And spectrum is not cheap. It's a very valuable asset. So we need to be, I think, better at how we regulate, how we specify what can be used. And then we need to be much more intelligent within our own networks, the right device and application on the right spectrum at the right time with the right capabilities. And then, of course, we have more and more intelligence available to us with the coming of AI and intelligent traffic steering and how we can combine things in a good way. So I think we can do a lot as an industry if we collaborate across all of those different groups.
So do you see, like Nokia, for example, the studies of Eamon that said between 500 and 700 megahertz per network? Do you see that as well from Ericsson and the studies you
I think
have done?
We have a white paper on spectrum, and I think we've said actually maybe 3 times more than that. But when I say that, let me categorize a little bit. It depends very much on the type of use case.
Yeah. Yes, that's right.
I would agree. That's a good target to have. I think we're aligned on that one. And then, I think we're a long way off from having massive immersive communication with holograms. That's a vision, but that's not the first thing we're going to do.
So, Eamon, when you talked 500 to 700, was that in urban areas, or you
Yes.
had specific use cases that you were looking at for
Yes,
that
I
specifically,
was
right?
looking at, for example, a specific use case like immersive communication. And when I compare what do I have in 5G and I compare it to the 6G, and I'm taking macro cellular deployment in a city. This is as an example where I have come with that number. This is only for a specific use case, this 500 to 700, which you find, it's a little bit challenging. I know
Yes.
that if you wanted to find it in a sort of the spectrum which we have it. But for that specific purpose, and if you wanted to have a network that could satisfy that demand, you need to have this additional spectrum for this macro deployment. And this morning I have been discussing with one carrier. He had the 3.5 gigahertz band. And he said that he have now, today, 2024, he had a bit of unable to provide the needed capacity. Yeah, he need an additional capacity. We did a lot of work in different technology advances, but it's also the technology advances have a limit. So in order to provide an affordable capacity, he need that additional spectrum. And if you deploy another band in the same site of the 3.5 gigahertz, you put another one in reusing the same site, you will come to that additional. So this 500 megahertz per network operator, which you see, it's a little bit a lot. Yeah, I know it's a lot.
It's an awful lot.
Yeah, it's a lot. But you have to take into consideration how you are going to do it from an economical point of view, reusing same sites as existing. So these are a bit of aspects.
But you need to start with 500, or if we think at introducing, we've got 5G, we get a 5G plus, maybe start with 100 or 100, like you don't need to start off with 500, right? What would be the steps to get to 6G in terms of spectrum? Anybody want to see what would be the first step?
Can I start? Sorry.
Go ahead.
So you are going to start, and you don't need to, you will have it in phases. Yes, and one of the phases which I see as a starting point, for example, starting by 5G advanced and repurposing the upper 6 gigahertz for 5G advanced and try to trial in that one, and then coming up to 7 and 8 gigahertz band, and maybe see how we are looking at for the macro deployment.
Yes.
But it's you started the C band. We have only just 100 megahertz per operator.
I know.
So I'm not expecting that in 2030 I'm going to get 500 immediately.
No.
But this is an
As we're
aspect that
hoping. Yeah. So that's a good. The upper 6 gigahertz.
Can I
Christine?
also add a point that is interesting in the deployment of 5G? Because let's be honest, but at the beginning, dynamic spectrum sharing was a solution to deliver as well the early 5G. So we've seen other bands being reused for what was a sort of 5G experience. So again, there's always a little bit of an organic move. Obviously, in the UK now we see quite a lot of 3.6 deployment. We're seeing 700, etc. But there is still a lot of use of DSS, because that's how you, in the end, and we're discussing before with Marie, you optimize your existing spectrum holding by making it share between different technologies.
Maybe I could comment on that, because I think Ericsson are a big proponent of spectrum sharing between 4G and 5G. So I think it's a very good point. We start with what we have today. When it comes to 6G and 2030, we start with the existing grid, and then we share dynamically the spectrum we have. So in 5G, the spectrum sharing was more limited for 4G, 5G on these FDD lower bands. But for 6G, we see an opportunity where you can also dynamically share on these TDD bands that exist today. And we also see an opportunity to make this, we've learned a lot during 5G, and there are many years to go before we get to 6G. So I think we can make it very dynamic and very efficient way to share. So as those devices come in that are 6G capable, you can gradually add them. So it's about a smart way of sharing resources.
Doug, you want to chime in?
I think technologically, there's a number of things that we can add on top of that. The way that we tried to do dynamic spectrum sharing in 5G was a very small baby step. One of the pieces that the technology crowd is looking at is, can we do dynamic spectrum sharing across dynamically reallocated heterogeneous networks, so that I can have a cell site that literally is changing its bands so that it can change in and out of a piece of spectrum that has to go back to somebody else, and yet the operator can then do reuse, which will not be as beneficial as having the other band, but is better than having nothing. And so there's ways that you can ebb and flow back through this, and the underlying hardware technology is now capable of this. The software stack should be able to move in that direction with things that we would think about in a RAN intelligent controller and moving in that direction. We, as a community, need to challenge the technology underpinning of what we're doing and say, how do we do those things that have the greatest fulcrum to generate the forward motion that we need to have?
But what about the impact on quality, network performance? You know, networks to date have been built on high power and let's say variable quality, but let's just say they're high quality networks where you have good coverage and good, usually when you want to use it. If you start all this sharing and you move your spectrum at the cell site from this person to this company, what's the impact on quality? Seems to me if you decrease quality, that's not really helping the industry.
I would assert that there's a fundamental error in your supposition at the beginning.
Okay.
And that is that we have good quality today. Because,
like I said, yes, it
because
varies.
I live in San Francisco. Until recently, my wife's sister lived in Reno, which is on a major highway. It's 280 miles. And you would think that this is on one of the major highways in the United States. You would have 100% coverage of 5G from A to B. For 50 miles, I have no 5G. For 20 miles, I have nothing. All right? I mean, so I will simply lay out and assert that we are not as good as we think we are, and we all can do more, and there's a lot of places that we can work together to make that happen.
Okay, I'll agree with you. We're not as good as we think we are, but we don't want to get worse, right? So,
Absolutely.
so we want to look to enhance quality and performance of the networks. That's why I'm just maybe pushing back on the
I think
dynamic sharing a little bit. Like,
but I think it varies, of course, from region to region and network to network. I'm based in Sweden, and it is very hard to avoid coverage. But they have built the network a bit differently. It's a lot of fiber connections, a lot of radios. So it's, and there are different economic and sort of, deployment aspects depending on the customers and the region. So there's quite a variation. I think when the network is built in a good way, we have very good quality. But then when we get to this spectrum sharing, especially if we're sharing with non-3GPP incumbents, it could be NATO, it could be satellite.
Yeah, that's right.
There are many incumbents. There's no free spectrum as such. Then I think we have to look at a broader range of solutions, and some of them aren't as optimal for either party, but as you said, it's definitely better than nothing, so we need to work together, I think. But
And sorry, can I just say, and this is why Doug has been talking a lot about technology. The regulator here is asking for technology solution because we know that we have a problem to enable this different type of sharing. We need technology solutions that are harmonized to actually make the most of the spectrum that is out there and the one that we want to make available for the future.
yes, amen.
Yes, this is a very good thing is that for your job is as a regulatory body, Christina, is you need to have a fair access to all of those services. And one of the things that what we look at in the 6G from a technology point of view, they should be shared by design, that they should be able to share with the incumbent. As you see that the bands which is being put down for discussion in the WRC 27, there are bands that have a different type of incumbent. And we need to think about, from a technology point of view, how they're making them share by design, so that the technology design itself, it should be able to share and coexist with such a kind of an incumbent. Not only just the dynamic sharing between two operators, but also the other incumbent, like the different incumbents, which they have a different applications that is a little bit need more high reliability and resilience type of application. Yeah, so we know that the 7 and 8 and the 4 gigahertz band, these are the type of the applications there is a bit of a challenging one, and we need to think about it. from that point.
So maybe just to move on, just maybe to another subject we briefly touched upon. You know, we talk, obviously, you know, usage is indoors. There's a lot of usage that's fixed, and there's so much spectrum needed for unlicensed because of that and Wi-Fi. But when we're talking 6G and all these immersive applications, if we just look at what we've been having for usage for the last, let's say, 5-10 years, are we missing what's coming? Which are we going to go back to having new applications which will require outdoor and broad coverage, as opposed to what we've been doing? And, you know, there's this tension between unlicensed and licensed spectrum. So is that something that's coming back for a need for licensed spectrum for outdoor applications and broad coverage?
I don't think you have a choice. I think if you look at the data that was presented in the first main presentation, and you recognize that the revenue models are going down, it's because we as an industry are leaving a lot of the applications that we had planned on monetizing in 5G are not enabled. If I am dealing in the state of Wisconsin and I want to have a whole bunch of IoT dairy cows, just to get a little bit ridiculous, I have no coverage. There's no way I can have IoT dairy cows. So I'm leaving that opportunity completely on the table. We pride ourselves on telling how much of our population is covered, but we don't actually, this is part of being honest with ourselves, how much of our geographic area is covered.
Not that much.
And not that much. In the United States, it's less than 20%. It's incredible. We cover 85, 95% of the bodies and the people that carry around our little cell phones. But these aren't creating any more revenue. The things that are going to create the revenue, that are going to sustain the investment, they're out there. That coverage and how we think about doing that, and they're not necessarily high bandwidth applications.
No, I agree. I agree.
Absolutely. Absolutely. You have to look also at the 600 megahertz
Yeah.
as one example that to satisfy the coverage aspects for 6G as well.
So
Or even
600
lower.
megahertz for 6G in Europe, in region 1, because it's already in other areas, right?
Yeah.
In North America, it's already there, deployed
Yeah,
for 4G.
Yes, and I would not say 600 per se, but it's 470 up to 600, 940. Okay, we have the 600 deployed in
Yes.
some other places, and we are going to review that band. But this will be a crucial band for satisfying the coverage demand.
We agree.
And we need to take it, and we need to take the outcome from the WRC 2023 into a review process and look how we can satisfy that demand.
Okay, so we got some agreement here. On
I think so, yeah.
We
I
have a
mean,
zone of
migration
agreement.
from these
Okay.
bands would be super important as well.
Okay, so and that will obviously help all these applications that are not being monetized. That would help partly.
Can
Go
I
ahead.
can I throw
Absolutely.
in a word that is private networks? Because in
No.
in the UK and Europe has followed through what we have tried to do for the farms, in our case for the ports, the airports, the construction sites as well as temporary solution. We have enabled private networks, and we've had mobile operator actually using the spectrum, 3.842 in this case, to develop those networks. Because again, you're trying to deliver such a specific solution for a specific use case that very often your broad, wide area coverage is not the right solution.
Right.
So again, I think it's horses for courses. Not every bit of spectrum is the same. It's still very, very important in delivering the application. But yes, at the beginning where it's all 5G, it's all going to be delivered via slicing, a lot of the solution in the end became private networks.
So we have 30 seconds to go. So I have the timer here. So if I ask each one of you, what's the first band where 6G might be deployed? What would be your answer? Or if you have an answer now, or you waiting to bet on it? Anybody?
I can start maybe. I think it will be deployed on at least one of the existing lower bands, but combined with hopefully something in the lower end of what we call the centimetric range. So something preferably under 10 gigahertz
Yes,
and mid-band.
7,
So
8.
we have this layer cake, and we
Yeah.
think we need all
So
with
maybe
Marie.
ideally a 600 and a 7 to 8 gigahertz.
Plus
All
3.5.
spectrum. Exactly. All
Amen.
existing
I
spectrum.
would see the coverage will come at the end, but we are going to start with satisfying the cities.
Capacity.
Yeah.
So I see the 7 to 8 is going
Yeah.
to be a crucial band to start with.
Yeah.
Okay. Doug, anything?
I would say the opposite. I would say we're going to start with the rural areas and because it's a lot lower risk. It's a
Okay.
lot lower risk. And then once we understand that the risk is managed in that lower footprint area, then we'll immediately move it into the cities. So the first place it probably sees a lot of deployment, I agree with you, is in 7 to 8 in the cities. But I think the first experiments, they're going to try to understand whether they can get new monetization pathways. Because it's the monetization pathways that as an industry we are missing today. And without them, it's going to get ugly.
And Christina, in the UK, which one?
I think it's a lot capacity first, to be honest. I'm with Eamon, and in terms of band, I'm with Marie. Existing spectrum, and somewhere in that 7 to 8 might be the best
Okay.
bet.
But 600 is not existing in the UK.
600 is not allocated in the UK.
No. Will it be?
We have got terrestrial television in
Yes.
that band, and
Yes.
the license is until 2034.
That's 2034. Okay.
Yeah.
Okay. I thought it was more term to 2030. But all right. Okay. Well, I guess we're out of time. And it was short, sweet, and some debate since we're on the debate stage. So thank you very much. If we can thank the entire panel.
Thank you, Joanne.
And thank you for attending. And I wish you a very nice day.